Hey boys and girls, this is lesson 6.7, Partial Quotients Division, Part 2. In this lesson, you will practice using partial quotients division to divide whole numbers with 3- and 4-digit dividends. Get that written down as well as today's date in your notebook, and when you're done, come on back. Okay, so here's your first question. So Mrs. Kelly needs to buy 112 bottles of water for a school party. The bottles come in packs of 4. How many packs should she buy? Try and figure that out. What could you do to solve that? Write it down in your notebook. When you think you have it, come on back. So, there's lots of ways that you could have solved it. Here are some of the more common ones. So you may have solved this using repeated subtraction. You would have gotten 112 cubes or pennies or any kind of counter, and then repeatedly taken away groups of 4 until none remained. When you added up those groups, the quotient would have been 28, because that's the number of groups of 4 that were made. So, definitely one way you could have gone about that would be repeated subtraction. It's not a very efficient way, but it would work if you had lots of time and lots of patience. And 112 of something, right? Okay, so that's one way. You may have partitioned a rectangle or used that same type of thinking, like meaning friendlier numbers, to break 112 into smaller chunks. Maybe you would have thought of 112 equals 100 plus 12. Then using what you know, there are 25 4s in 100. And there are 3 4s in 12. So if you added together the 25 and the 3, which I got from here and here, I would have ended up with 28, so there are 28 4s in 112. I could have done that, or I may have done partial quotients division, and this is one of the ways that you could have divided it. You wouldn't have to use just these, but you could have used these or others, and you would have ended up with 28 as your partial quotients answer as well. Any of those ways work. So let's ask another question. So Emily bought 162 stickers to put in gift bags. She wants each gift bag to contain 6 stickers. So how many gift bags can she make? So the problem that we're trying to solve is 162 divided by 6. First thing I would do, make an estimate. So I'm going to estimate 150 for this 162 and 5 for the 6, because that's pretty easy for my brain to say 5 times 3 equals 15, and then I'm going to append the 0. So I know it's 30 bags. She could make 30 bags. So that's an estimate. So a great way to start is to use a series of at least but not more than easy multiples of the divisor. So, for example, I could start with 10 and ask myself, are there at least 10 6s in 162? 10 6s. Well, yes, because 10 times 6 is 60, and 60 is less than 162. So I know there are at least 10, so I could start there. But I'm going to go on because 162 is a pretty big number and 60 is not close. So then I could say, well, are there at least 20 6s in 162? And again, I'd be able to say yes, because 20 times 6 is 120, and 120 is, again, still less than 162. Getting closer, but still less. So then I might even try, well, are there at least 30 6s in 162? And then I'm stopped there, because no, 30 times 6 is 180, and 180 is greater than 162, so I can't go that far. So let's go back to the highest one I could do, which is there are at least 20 6s in 162. So that's the beginning of my partial quotients division problem. 6 times 20 equals 120. I'm going to take that away from the 162. Now I have 42 to contend with. I'm definitely not done with this because this amount is more than this. So there are more 6's in 42. But I'm going to go on to the next screen so I have enough room. So moving on to this. So I go on to say, so how many 6's are in this 42? Well, an easy one for me, 6 times 5 is 30. So I could subtract 30 and see how many I have left, and that's going to give me 12 left. So then I'm asking myself, are there 6's in 12? How many? Well, I know that fact. 6 times 2 is 12. So I can do that, subtract, I end up with 0, which means I'm done. And then I add my partial quotients to get my quotient. So my quotient is 27. I'm going to check to see, is it close to my estimate of 30? Sure is. So I can feel pretty confident that I didn't make any error, and I'm in pretty good shape. So that's one way that I could do it, the way that I just showed you. But another way, if I'm not comfortable using numbers bigger than 10's, I could have done 6 times 10 is 60. Take that away. I could do another 6 times 10 is 60. 6 times 6 if I know it. So I could go there. I could do this. 6 times 20 is 120. And then I could have seen the 42 and said, oh, well, that's 6 times 7. I know that fact and gotten that way. So any of these is great. If you have yet another way to have done it, certainly fine, as long as you end up still with the 27. That means your math would have been correct. So what can we notice about all of these quotients? Well, they're all 27, which means that any of these ways are okay. And then what's different about these three different ways that I could have solved it? We use different multiples of 6. These are different multiples of 6 to break it into parts. And any of those ways is fine. And again, any way you come up with is fine as long as you ended up with 27, because that would mean your math was correct. So let's try another problem, a bigger one. A 4-digit now. A 4-digit dividend that we're going to divide by 7. So 1,925 divided by 7. So we will follow the same process as before, except we're going to start with bigger numbers in our series of at least, but not more than questions. Of course, the first step will be an estimate, so we'll know if we get something crazy. And to do this problem, I would probably maybe start with either one of these two. I might do 2,100 divided by 7, and the reason I might choose that is I'm dividing by 7, I know my facts, and I know that 7 times 3 is 21, so I might move this up to 2,100, so I can do 7 times 300 equals 2,100. So I could have an estimate of 300, or I might say, well, 1925 is close to 2,000, and I can divide 2,000 by 10 pretty easily to get 200. So I'm going to figure my answer is somewhere between 2 and 300. Either of those is great. So here come the problems that I would be able to do. I can start with, are there at least 100 7's in 1925? Whereas the last time I started with 10, now because my number is so large, it's a 4-digit, I'm going to start with 100. And I'd be able to say yes, there are, because 100 times 7 is 700. 700 is less than 1925. In fact, it's way less, so I won't stop there. I'll try 200 7's. And again, yes, because 200 times 7, 7 times 2 is 14. There's my 2 zeros, so my 2 zeros in my answer. And that's still less. So I'll try for the 300, but no, that doesn't work because 7 times 3 is 21. The 2 zeros gives me 2,100, and that's too much. It's more than 1925. So I'd start with the 200. 7 times 200 is 1,400. Then I'm going to subtract that away. That leaves me with 525. So I'm going to say to myself again, okay, so I want to see how many 7s are in 525. So now I'm going to say, try and do, can I do 100 7s? Well, no, 100 times 7 is 700. That's more than 525. So now I'm going to drop back to some smaller numbers. How about 50? Are there at least 50 7s in 525? There are, because 50 times 7 is 350. 350 is less than 525. So I know I can do that, but could I go a little bit bigger to give me less of these that I have to do? Yeah. Could I go a little smaller because I don't know my facts as well? Could I just start doing 10s right here? Yeah, I could do that as well. But because I know my facts pretty well, I'm going to keep going up to try and get a little bit closer to that 525 number. So, are there 50? We said yes. Are there 60? Well, yes, because 60 times 7 is 420. That's still less than 525. So let's try the 70. So 70 7s? Yeah, that's 490. That's less. So how about 80? Well, no. 560 is greater than 525, so that's too much. So I'm going to go back to the 77s. 77s is 490. I'm going to put that underneath the 525, subtract to see how much more I still have left. You can tell, of course, when I did the subtraction problem that I did have to cross off the 5 because I'm borrowing from it, leaving me with 4, and the 2 becomes a 12, right? And then I subtracted that, I get 35 left. So now I'm asking myself, how many 7s in 35? Well, that's a fact I know, that 7 times 5 is 35. So I can just go ahead and write that, do this, subtract it. I have nothing left, so I know I'm done. Notice when I wrote these down, I kept them in place value columns, so it's easy for me to add straight down the columns. 5 plus 0 is 5, 7 plus 0 is 7, and 2 plus nothing is 2. So I take this back to the question, and it was asking how much money. Oh, I actually didn't put that part in for you. I'm sorry. It was a question about money, and it's $275, which is why I put the dollar sign there for you. So, is it close to my estimate? So I know that I'm done. Yep, we said between 200 and 300. And it's 275, so I'm right in there. I am in good shape as far as that goes. So page 206 in your math journal is giving you practice for this kind of problem. I went ahead and did the first one here, and we'll go over that, and then you're going to complete this page and the next. There's not very many problems on 206 and 207, so you'll complete those before you are done and bring that completed to the lesson. So on page 206, it's asking you to do some partial quotients division. Problem 1 says, there are 184 plants to put into pots. Each pot can hold 8 plants. How many pots are needed? First, we're going to do an estimate for ourselves. An estimate I could easily do. 200 is taking the place of the 184. 10 for the 8, because I can easily do 200 divided by 10 in my head and know I get 20. Right? 2 times 1 is 2. There are 2 zeros, 2 zeros. So that's my estimate. When I actually do the math, I'm going to set it up like this partial quotients. And I'm saying to myself, okay, how many 8s in 184? Well, I know I could do 8 times 10. That's 80. That's really low. So I'm going to bump that up and try 20. Are there at least 20 8s in 184? Indeed there are, because 8 times 2 is 16. I'll append my 1 0. 8 times 20 is 160, and that's less than 184, so that's the one I chose. Subtraction problem gets me 24 left. I'm asking myself how many 8s in 24. Well, I know that math fact. I know it's 8 times 3 is 24. So I'll write that there, do the subtraction. I have none left. I add my 2 partials together to get my grand total answer of 23. Is it close to my estimate? Yes, I can consider myself in good shape and